Welcome back children. Today we are going to learn about a new topic, matter and chemical formulae. Right? Shall we start the topic? Yes. Now, what do you know about matter? Any guess? Yes. See, we can see different objects, living or non-living matter, wherever near to us, is it not? We can see different objects surrounding us in our daily life. So, they are in different shape, color and sizes and all, isn't it? So, anything is made up of matter. Any object is made up of matter. Clear children? Yes. Yes children. Now, the proper definition for matter. Anything that has mass, occupies space and can be perceived by our senses is called matter. Clear? Yes. Matter exists in three states: solids, liquids and gases. The matter is made up of tiny particles called atoms. Clear? They are basic building blocks of any substance. Clear? Now children, let us study the properties of an atom. Okay? An atom is the smallest unit that has characteristic properties of a substance. Okay? In solids, atoms are tightly packed. In liquids, atoms are loosely packed. In gases, there is a lot of space in between them. Clear children? Yes. Now children, let us have a look on mind map. Okay. Now matter, anything that has mass, occupies space, can be perceived by our senses is said to be as matter. Matter is classified based on composition, two types, that is atoms and molecules. Atoms are tiny particles, molecules they are smallest unit of matter. Okay. Now, atoms are divided into three types: electron, proton and neutron. Electrons are negatively charged, protons are positively charged and neutrons are no charge. Clear? Now, matter is further classified into two types: pure substances and mixture. Pure substances is further divided into two types: elements and compound. Elements, they are made up of same type of atoms. Clear? And about compounds, when two or more elements combine, then that is termed as compounds. Clear? Then about mixture, that is when two or more substances are physically mixed together, then it comes under mixture. Clear? Yes children. Now you can have a look at the chart for the structure of an atom. The center of an atom is called the nucleus. The center of an atom is called the nucleus. It consists of protons. It consists of protons which are positively charged and neutrons. Okay. The outer part consists of electrons that keep on revolving around the nucleus in a circular orbit. Protons are positively charged, neutrons have no charge and electrons are negatively charged. They are much smaller than protons or neutrons. Clear children? Yes children. Now, different atoms have different number of subatomic particles. Clear? An atom is electrically neutral because it has equal number of protons and electrons. Clear? An atom can lose or gain or share its electrons. Clear children? Yes. An ion is a charged particle formed from an atom by the loss or gain of electrons. Yes children. Now about molecules. A molecule is the smallest unit of matter which can exist independently. Clear? A molecule is a group of two or more atoms that are chemically combined together. For example, H2, a molecule of hydrogen, consists of two hydrogen atoms. Okay. So, they are of same elements. And then another example, CO2, a molecule of carbon dioxide, consists of one carbon and two oxygen atoms. They are of different elements. Clear? So, children, as of now we have learned matter, atoms, and atoms are further classified into three types: electrons, negatively charged; protons, positively charged; neutrons, which are neutral. Okay. Then about molecule, which is the smallest unit of matter that can exist independently. Clear? Now children, matter is further classified into elements, compounds and mixtures. Clear? So now about elements. Element is a pure substance, consists of only one type of atom. One type of atom. So there are 118 known elements so far. For example, hydrogen, oxygen, copper, iron, sulfur and so on. Clear children? So we can have a look on molecules of elements. So they are oxygen, they are hydrogen and they are nitrogen. Clear children? Yes. Now about compounds. A compound is a substance formed when two or more elements combine in definite ratio chemically. Clear? Compound is made up of same combination of elements which is combined in a fixed proportion of mass. Clear children? Yes. The constituent element of a compound cannot be separated by physical methods such as evaporation and filtration. Clear children? Yes. For example, water, which has two elements, hydrogen and oxygen. Carbon dioxide, that is CO2, is made up of one carbon and two oxygen element. Clear? Yes. Now about molecules of compounds. So two hydrogen and one oxygen, and this is a picture of carbon dioxide, one carbon and two oxygen. Clear? Yes children. Now about the third type, mixtures. Okay. Mixtures are substances in which two or more substances are physically mixed together in any proportion. Clear? The constituents in a mixture can be separated by physical methods. They are not present in any fixed proportion. Clear? The individual properties of all the constituents of a mixture are retained. For example, water mixed with salt, water mixed with oil. Clear children? Yes. Yes children. Now about chemical symbols. Okay. Scientists use chemical symbols to represent elements. Each element has its own unique symbol. Clear? John Dalton used symbols to represent elements. For example, hydrogen is represented by symbol H. Oxygen is represented by symbol O. Clear children? Now children, let us have a look on Dalton's symbols. So oxygen, this is the respective symbol, hydrogen, nitrogen, sulfur and phosphorus. Children, now about atomicity. Okay, many elements cannot exist as independent atoms. They combine to form molecules containing two or more atoms. The number of atoms present in a molecule of an element is known as atomicity. Clear, children? Yes, children. Now, atomicity is further classified into three types: monoatomic, diatomic and polyatomic. Clear? So, first about monoatomic. So, when the atomicity is 1, it is termed as monoatomic. So, for example, helium, neon, argon, sodium and potassium. Clear? Above, the second classification, diatomic. So, when the atomicity is 2, it is termed as diatomic. So, for example, hydrogen, oxygen, nitrogen, chlorine. Clear, children? Yes. Now, about the third classification, polyatomic. So, when the atomicity is more than 2, it is said to be as polyatomic. Clear? So, for example, ozone, phosphorus, sulfur, boron. Clear, children? Yes. Children, now about chemical formula. Okay. So, chemical formula is a short form to represent a molecule of a compound. Clear? It uses symbols for all elements present in the molecule and indicates the number of atoms of each element. Clear, children? Yes. For example, one molecule of water H2O is made up of 2 atoms of hydrogen H and 1 atom of oxygen O. Okay. So, the chemical formula of water is H2O. Clear, children? Yes. Now, about another example, sodium chloride, NaCl. Okay. So, Na represents sodium and Cl represents chlorine. Okay. So, here Na in NaCl has 1 atom and then Cl has 1 atom. Clear? So, this is what another example. Yes, children. Now, about valency. Valency is defined as the combining capacity of an element. Clear? Yes. It plays an important role in writing the formula of a compound. Clear? So, children, you can have a look at a textbook at page number 66. There are 2 tables, table number 5.3 and table number 5.4. Okay. So, 5.3 table is about valencies of some common elements and 5.4 is about valency of radicals. Clear? So, you are supposed to remember this. Now, children, let us learn to write a formula. Okay. So, here step 1, write the symbols of the constituent elements or ions. Okay. So, for first example, water, you are taking hydrogen and oxygen, H and O. Clear? Then, step 2, below each element, write its valency. Okay. So, for H, 1 and for O, 2. Okay. Then, step number 3, interchange the valencies and write them as subscripts. So, when we are interchanging here, for H it is 2 and for O it is 1. Clear, children? Yes. Now, about the fourth step. If the valencies are divisible by a common number, simplify the numbers in the subscript. otherwise retain them as such. Clear? So, here we are making it as H2O. H2O. Clear? Another example, magnesium sulfate. So, here we are taking the symbol as Mg and SO4. Okay. And then in the second step, we are just writing the valency, that is for Mg 2 and for SO4 2. Clear? And in the third step, we are interchanging the valencies, that is for Mg 2 and for SO4 this 2. Clear? And then the final step, since both have Mg and SO4 have same valency 2, it cancels out. So, here you are getting Mg SO4. Clear? So, this is the way to write a formula. Yes children, now about chemical reaction. Okay. So, chemical reaction is a process in which one or more substances undergo a chemical change to form new substances. Clear children? Yes. Now, let us study about an example. Okay. So, 2H2 plus O2 gives 2H2O. Clear? So, hydrogen and oxygen molecule react to form water. Is it not? Yes. So, the arrow mark represents direction of reaction. Direction of reaction, that is from left to right. Clear? Then elements or compounds that react are called reactants. Reactants, which is there in left hand side, LHS. Okay. And then elements or compounds that form as a result of reaction is said to be as products. Is said to be as products, which is there in right hand side or RHS. Okay. And then number of atoms of each element on two sides of equation should be equal. Okay. The number of atoms of each element on two sides of equation should be equal. Okay. And then it results in an equation, no? The resulting equation is called balanced chemical equation. Balanced chemical equation. Clear children? Yes. Yes children. Now another example, Fe plus O2 gives Fe2O3. So, Fe stands for iron, O stands for oxygen. Clear? So, in this formula, O2 means 2 atoms of oxygen. Clear? And then Fe, 1 atom of Fe or iron. Clear? So, Fe2O3 means 2 atoms of iron and 3 atoms of oxygen. Clear? Yes. Now, we are going to balance this equation. So, now we can add coefficients to balance number of atoms. Okay. So, we should never change subscripts. We should only add coefficients. Clear? So, add coefficient 2 in front of iron oxide molecule, that is Fe2O3. Here we want to add coefficient 2, that is 2 Fe2O3. Clear children? Yes. And 4 in front of Fe. Here we are adding coefficient 4 in front of Fe. Now the equation is 4 Fe plus O2 gives 2 Fe2O3. Clear children? Yes. Now children, in this equation iron is balanced. We need to balance oxygen. We need to balance oxygen. So, in the right hand side 6 oxygen atoms are there. isn't it? 6 oxygen atoms. 3 into 2, 6 oxygen atoms. And the left hand side, 2 oxygen atoms are there. So, to balance oxygen, add coefficient 3 in front of oxygen in the left hand side. Here it is 6, here it is 2. So, to balance we are adding coefficient 3 here. So, the equation is 4Fe plus 3O2 gives 2Fe2O3. Clear? So, this is now a balanced chemical equation. So, children, you are going to write the formula for zinc hydroxide and magnesium hydroxide. Okay. So, write the formula and submit it in your class email ID. This is your activity. Clear, children? Yes. Children, now let us play a game. I have kept some things together. Let us have a look one by one and identify it as element, compound or mixture. Now children, what is this? This is aluminium foil, isn't it? Yes. So what is this? Is this element or compound or mixture? Children, it is made up of aluminium and that is a pure element, isn't it? Yes. So, this is an example for element. Now, children, what is this? This is water. So, the molecular formula of water is H2O, which is in fixed proportion. So, this is one example for compound. Clear, children? Yes. Now, children, what is this? This is table salt. So, the molecular formula of table salt is NaCl. So, this is another example for compound. Yes, children. Now, a cup of water and some table salt. Now, I am going to add a pinch of salt in water. So, I am going to mix it. So, this is water with table salt. So, what is this? Element, compound or mixture? Children, this is one example for mixture. So, now children, you can see water which is completely mixed with table salt. So, this is one example of mixture. Now, children, here I have kept a cup of water. So, with this I am going to add little amount of oil. Okay. So, now you can see that 2 layers oil in the top layer and water in bottom, isn't it? Yes. Now, this is an example for again mixture. Now, children, this is one example of air filled in a package. So, we can easily distinguish oxygen, nitrogen and other gases in the air. So, this is another example of mixture. So, children, you can see this. This is activated carbon powder. So, this is one example of pure element. So, children, that's all about the chapter. We have come to the end of this chapter. So, after watching the video, read the chapter thoroughly and practice well. Thank you, students.